Did you answer 1 and 2 again, Nick?
No, I don't know how.
Oh.
What'd you guys put?
I was going both ways. I wasn't sure.
1 true, 1 false. I don't even think I participated this week, so. All right.
You jump into it?
Yeah. Number 3, what is the total area under a density curve must equal?
1.
Yes. Under certain circumstances, the density curve can drop below the x-axis. False.
False.
A normal density curve is symmetric.
True.
True.
Yeah, for normal. Okay. Use the following image to answer questions 6 and 7. Does your guys have 0.8413 at the top for area?
Yes.
Okay. Which of the following elements in the figure represents the z-score of this image? C?
Yes.
Which of the following elements in the figure represent the probability that the random variable z will be greater than b? Everyone cool? We're good?
Yeah.
All right, we're halfway through, almost. Okay. This work stuff's going to probably hit the fan. Okay.
Yep.
According to the sweet numbers rule, what proportion of the data from the bell-shaped distribution will be within 1 standard deviation of the mean? 68. Right?
Yes.
68.
Yep, that's right.
Suppose random variable z has a standard normal distribution. Use a normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. Example. Okay. Do you guys have that open?
No, I'm going to pull it up right now.
Okay. Pull it up.
I have mine open.
No. Did you already plug in the top number?
Nope.
We'll be using this thing like a ton.
So it's -1 to 1, right?
Yeah, this is the score anyway.
And they're looking for the area. So isn't it just 0.3173?
Should be, because that's what it always is.
I don't see anything different with this one than the normal one. So then just change the to -2 and 2 for the next one.
So 9 is 0.317.
Yeah.
Okay. Yeah, because all you have to do is change one side, as long as the 2 are highlighted, and you can do it.
Yep. So 10 would be 0.0455.
Yeah, 455, because they're trying to trick us with that significant figures.
Yeah.
0.46.
Yeah, okay. Sorry, I just got done doing chemistry, so I was thinking significant figures. So, yeah,
That was number 10.
Hello.
0.046.
Yeah. Okay, suppose they're standard.
Suppose random variable zombie has a standard normal distribution. Use the app again. What is 3 and 3?
0.003?
Yep.
0.0027. Is that right?
Give your answer as a decimal, accurate to 3 decimals. So yeah, 0.003.
Okay.
Okay, number 12. Look carefully. Are you carefully looking? Okay. What do you observe? I can't observe anything. Okay. The values match the rule.
The probabilities don't double, right?
Yeah.
And it doesn't increase.
Yeah.
Oh, wait.
Well, the z-score increases, but the area does not decrease.
Right. Okay.
It increases also.
So I'm thinking, yeah, the only one is the value match.
Yeah.
Okay.
Okay. The amount of protein that an individual must consume is different for every person. There is a solid theoretical idea that suggests that the protein requirement will be normally distributed in a population of the U.S. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body weight. The population mean protein requirement in adults is 0.66 grams, and the population standard is 0.07 grams. Use the information to answer the questions below. Okay, so 13. Oh, the standard deviation. Okay, so what proportion of the population have a protein requirement that is less than 0.60? So do we just highlight the blue side now? Or the left side blue? Because that'd be what's less.
Yeah, so you'd have to do some calculations in this one. You'd have to take your 60 and subtract your population mean, which will give you a negative 0.06.
So it's 0.60, what is it, times or divide or minus?
Minus the mean over the standard deviation. That gives you your z-score. Then you can use that z-score on that normal probability applet, I think.
Yeah.
Should I grab my calculator real quick?
Yeah, I gotta pull up that equation. It's variable minus mean divided by the deviation, right? Yeah.
Yeah.
Calculador the Explorer.
Oh. Okay, what I got's not right, so.
What'd you get for your z-score?
I got. Did you put it into the little thingy?
Mm-hmm.
The graph?
So wait, we plug this into the area? Or is this the z-score?
This is the z-score that we just calculated. And you'll plug it in there, then the area should be our percentage at that 60. But the thing is, like, you have to click a couple things on the normal probability applet. So our positive z-score is our highest point, and anything less than that under that curve is going to be in our area.
Can you show it on your computer shared screen?
Yeah. All right, is that showing?
Yeah, you're good.
All right, so you've got here in your z-score, which we just calculated. I put 0.8.
Oh, I didn't put mine in a decimal. That's why it's not showing up right.
So wait, was yours not 0.857?
It was. I just changed it.
Oh, okay.
And then you can sit there and mess around with. Oops, I just changed it. I clicked on it again. Dang it. 0.857. It'll calculate everything, and I can go through and tell it which ones I want to calculate.
And it's just the left one, correct?
Yeah, everything that's less than that. So it'll just be this area right here, which should be 0.804. So that's 80%. 80.4%.
All right, so we'll leave yours on screen share as we do this. So,
okay,
if that's cool.
Yeah.
Okay, so we're gonna do
0.8.
804.
857. No, sorry, that was my bad. I gotta plug it
Wants
in.
it to 3 decimal places.
Yeah.
So all we're gonna have is 80.430.
Yeah.
Or give your answer as a decimal. So 0.804. There we go.
804. Yeah. Okay. So now we do it again, and then you just switch it from that to the right side, correct?
Yeah. Wait, that's the same thing.
0.196.
So how come the middle isn't highlighted this time like it was last time?
Because it's above
Yes,
The point that.
this is our 60 gram mark, or 0.60 gram mark.
Oh, okay, that's what it was.
Anything less than that, and this is all over that.
Okay, so 0.196. Okay, so now all we have to do is change to 70 now. So 0.70 minus 0.66 divided by 0.07 gives us 0.57143.
Yeah,
So,
that's 0.57.
plug that in.
So 0.284. Is that, wait, less than 70?
Yeah, change yours. Yeah, so
0.716.
we got what I got. 0.716. All right, who wants to read the last one?
I can. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7 grams. Hint, remember that to find the area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Give your answer as decimal accurate to 3 decimal places. So it wants it less or more than 0.6 but less than 0.7. So our 0.6 was...
So shade to the left of each z-score. So each z-score, that'd be the middle and the left again? As far as being highlighted?
Calculate.
That should be, yeah.
Small area from larger area.
So wait, how do we... Oh, shoot. I don't understand.
I'm a little confused too. Hold on, give me a second. 0.6 minus 0.66 equals 0.7.
So between 60 and 70, what do they say if there's like...
Okay, are you looking at my screen?
I am now.
Okay, I don't really understand what it's saying about shading to the left. This makes sense in my head. I don't know if this is what it's talking about. But this is the calculation for things that are larger than 0.6. And we can get our area underneath here. And if I go through and I change that to 0.7, it's going to give me some value right around here. And I can do the greater than values as well. Then I could just subtract the area of the 0.6 from, or 0.7 from the 0.6, and that'll give me the leftovers in here that are still valuable. Does that make sense?
Yeah.
So you're just subtracting them from each other?
Yeah. I mean, that's the only thing I can think of. But I don't really... Between two values, say to the left of each z-score you calculate, and then subtract the smaller area from the larger area.
But wouldn't that just give you 0.66 again if you're subtracting them? Or did I subtract them backwards?
So that's 0.196. Hold on. 0.716. 0.04. Okay, so this is the other thing. This could be maybe what it's talking about, doing that, what I just talked about in reverse, though. Because if you look at number 13 and number 15, we've calculated those already.
Right.
In that direction.
Uh-huh.
And so you subtract your 0.716 from your 0.084, and that's going to give you what's in between those 2 points.
Wait.
The 0.088.
So subtract from each other?
Yeah, so it says if you shade to the left of each z-score, which gives us answers for 13 and 15, and then subtract the smaller area from the larger area, so 716 from 804, and that's going to give you a positive answer, which is 0.088, and that's the probability the randomly selected observation will lie between two values.
So you take the larger number, subtract the smaller number, and that's it?
Yeah, because you're gonna take away that portion that's not included in there, and so that's where that smaller area comes in. And the leftover is what's between that 0.7 and the 0.6 mark.
So we're not even using the mean right now because we use that to find what 0.6 and 0.7 are.
Exactly.
Okay, so it's 0.880.
0.088.
Round to 3, accurate to 3 decimal places.
0.088. There we go.
Oh, 0.88. Wait, I thought it was negative if we did it the other way.
No, because you're always going to have the positive area, and since you're subtracting the smaller from the larger, you're always going to have a positive answer.
Does that show up on the probability applet at all, or is that just math in general?
For the answer to 16?
Yeah.
Basically, just took the answers from 13 and 15, which we could calculate those again, but those are already our calculated answers. Those are going to give us our proportions for everything left of both of those z-scores.
Okay.
And then we just subtract the smaller one from the larger one. And it tells you there, it says make sure your answer is positive.
Because it is a negative number, you just make it positive?
No, it's positive.
So maybe my numbers are wrong. Wait, what do you have for 13 and 15?
0.804 for 13.
Okay.
And then 0.716 for 15.
And you take 716 minus 804?
No, 804 minus 716.
Oh, okay, okay.
So you subtract the smaller from the larger.
Okay. Which gives us 0.088.
0.088, yes.
Okay, that makes sense. Did you catch that, Brooklyn? You're in and out of time.
Yeah, I think I understood what happened. It said that you guys couldn't hear me, and then it disconnected me, and then I'm back, though.
Luckily, it was still recording.
Yeah. Well, it said it stopped recording, and I was like, crap. And then it said it was back recording, so I was just like, okay.
He'll figure it out. Okay, so this is the probability that random selected observation will lie between the two values. Okay. That makes sense to me, because we took what we had and then found the difference between them, and that was it. Mm-hmm. So, makes sense to me, unless anyone else has any other question about dogs sniffing bowls and then finding the percentage and then finding out you were wrong the whole time.
Should we go through our answers real quick?
Yeah.
Yeah.
That was a lot of decimals to write down.
Yeah, it was.
Yeah, 1 and 2 are true. 3 is just the number 1. Do we have to put like a decimal or anything, or just put 1?
I think just 1.
I think it's just 1.
All right, 4 is false. 5 is true. 6 is C. Z4 is, yeah. 7 is B. Just double checking. Okay. Number 8 is 68. Number 9 is 0.317. Number 10 is 0.046. 11 is 0.003. Number 12, the values match the 68, 95, 99 rule. Number 13 is 0.804. 14 is 0.196. 15 is 0.716. 16 is 0.088.
Perfect.
Looks good.
Oh, that sucks.
What?
The grade you'll receive. That doesn't make sense.
What?
Did you guys already submit?
No, not yet. We fail it?
Kinda. It wasn't failing. It's not passing. What the heck?
Huh.
Use normal output to answer this question. What portion of values from this? Okay, then what's the answer?
Which one was it? We can look at it again.
So all the ones except for 0.716 on so 15's right, 13 and everything else is wrong, and then 9 through 11's wrong.
What the heck?
Seriously?
Yeah.
Alright. 13. What proportion of the population have a protein requirement that is less than 0.6 grams? Give your answer as a decimal accurate to 3 decimal places. Alright, so we said 0.6. Population mean is 0.66, so that's going to give us a difference of negative 0.06. And divide that by 0.07, which is our standard deviation. And gives us negative 0.857, which we plug in.
0.86.
That's so retarded.
The heck?
Have you guys submitted yet? Because I can explain the answer afterwards since we're still recording.
Proportion of protein required is less than point.
Yeah, I just submitted. That's so stupid.
I know. We could have just shaded it wrong.
That's possible.
Because the answers are correct, they're just switched.
Yeah. Well, I considered that, but when I did the calculations before, it didn't seem right to me, so I didn't say anything. But I didn't get that answer, so it doesn't. I don't know.
And then 16, I'm trying to figure out. Man, we would have had that like whole last part right if those two numbers were switched.
What?
I'm trying to figure out why 9 through 11 is incorrect. Oh, you know why? Because it's just supposed to be 68, 95, 97.3. Right? Wrong? I don't know.
No, that doesn't make sense. Because I thought all we had to do was put in the -3 and 3 or whatever, and
I don't know. That made sense to me. I'm confused why we got it wrong.
I don't like this class anymore. Proportion of the population of protein currently is less than 0.6.
So through 9 through 11, were we just supposed to highlight the middle part? But that would just give us the 95, 99.7.
Yeah, but it comes out as the 0.6825.
Yeah, which is 68, 95, and then goes to 99.7.
Right. But so how they have it is, were we supposed to round 3 or is it just 2? Because the way they have it in the graph, it's 0.683 technically.
Oh, unless that's what they were looking for, that is so dumb.
But it said round the decimal. 68 isn't a decimal unless we put it as the 683.
68.3.
Is it supposed to be 68.3 though?
And if it's between, I don't know.
For which one are you looking at?
Just
9.
11. I don't know, even his example answer was like, if the answer is this, you would enter that. And it's like, okay, that's pretty close to what we would have had.
Right, but if we did the 68.3, it's still going to be 0.683.
Yeah. That's dumb. So I don't understand 13, though. Why is it...
I was just thinking that.
I don't either.
Why are they switched?
So we have the number correct, and then it's just like the whatever 1 minus that answer would be. There's your answer.
Because we had 0.84, right?
804,
No.
yeah.
Yeah, sorry, 804.
Is it because we had the negative z-score and we went from the positive z-score? Is that what screwed us over?
So less than 0.6.
But then are we still calculating the difference then to get 16?
Well, yeah, it was exactly what Brandon said. It was perfectly right, but our answers from 13, because they weren't the right answer, wouldn't give us what we needed for 16. The idea was right, it's just our number was wrong in the beginning.
Right, so if we were to like re-go through it, it'd be 13 and 15's the difference, right?
Yeah, it'd still be 13, or, yeah, 15 minus 13.
So 0.5. Okay, why is it that I'm coming out with not 3 decimal places for 16? What the heck?
The 7.716 minus 0.196.
Yeah.
Doesn't it give you the 0.520?
Hold on. 6 minus... Oh, that's wrong. Hold on. Oh, okay, there we go. Now it's doing it.
Yeah.
Okay.
Dude, I wish there were 2 tries to this homework stuff.
No kidding.
I'm still not understanding 9 through 11 though, because it's like I don't know, just six. I don't know, whatever. Usually nothing you can do, but because how do you put 68 into a decimal? Because we didn't even. I guess we get 68, but in the thing it's
Just
0.68.
3. That's really it. Unless, I mean, if that's the right answer, it doesn't say on the thing, but that would be the only thing that would explain that answer.
Yeah. Because let me see if I didn't try the -2 though. -2. Whoa.
5, whatever, or 4 something.
0.95. Yeah, that's probably what they were looking for.
So dumb.
Yeah.
All right.
Now you know for your homework.
Yeah, you want to turn off the recording because that's all we need.